Good morning, students. Welcome to 9th Science, Unit 14, Acids, Bases and Salts, Part 2. Now let us recall what we learnt in the previous class. Introduction to acids, classification of acids, properties of acids and uses of acids. Aqua regia. Aqua regia is a mixture of hydrochloric acid and nitric acid HCl and HNO3 prepared optimally in a molar ratio of 3:1. It is a yellow-orange fuming liquid. It is a highly corrosive liquid. It is able to attack gold and other substances. Then the chemical formula of aqua regia is 3HCl plus HNO3. Solubility in water. It is miscible in water. The melting point is minus 42 degrees Celsius and the boiling point is 108 degrees Celsius. What are the uses of aqua regia? It is used chiefly to dissolve metals such as gold AU and platinum PT, and it is used for cleaning and refining gold. The second one, bases. For example, NaOH, KOH. Bases are substances that ionize in water to form hydroxide ions, OH minus. Bases that are soluble in water are called alkalis. What are alkalis? Bases that are dissolved in water are called as alkalis. So, alkalis are bases, but all bases are not alkalis. Now, bases, calcium oxide, the molecular formula is CaO. The ions formed is Ca2 plus and O2 minus. Here only one oxygen. Here can be replaceable, so that is 1. Sodium oxide, Na2O. 2 Na plus, here 2 sodium, so here put 2. O2 minus, so here only one oxygen, so the replaceable one is 1. Potassium hydroxide, KOH. K plus and OH minus. That is, here only one hydroxide can be replaceable one, so here that is 1. Calcium chloride, CaOH twice. Calcium hydroxide, CaOH twice. Ca2 plus OH minus. Only one hydroxide ion. Here Ca2 plus. Here, look at here 2. So here OH twice means 2 hydroxide can be replaceable 1. Here because hydroxide it has a valency 1, so you have to put 2. Here have to put minus 1. Here aluminum hydroxide, AlOH thrice. Al 3 plus. Here OH minus. Here how many OH? 3 OH. So 3 OH can be a replaceable one. So the number of replaceable hydroxyl ion is 3. So here the first one, how many oxygen can be replaceable? 1. Only 1. Here in sodium oxide, how many oxygen can be replaceable? 1. Only 1. So here 1. Hydroxide, here also only one hydroxide ion can be replaceable 1. So the number of replaceable hydroxide ion is 1. Calcium hydroxide, here CaOH twice. Calcium has the valency 2. Hydroxide has the valency 1. So CaOH twice. According to crisscross method, CaOH twice. Calcium it has a valency 2 and hydroxide it has a valency 1. Here 2 hydroxyl ion can be replaceable 1. So the number of replaceable hydroxyl ion is 2. Aluminum hydroxide, AlOH thrice. Here 3 hydroxide ion. So here aluminum has a valency 3 and hydroxide it has a valency 1. So here 3 hydroxyl can be replaceable 1. So the number of replaceable hydroxyl ion is 3. Classification of bases. The first one, A. Based on their acidity. In bases, you have to find the acidity. What is acidity? Number of replaceable hydroxide ions present in one molecule of a base. Bases, you have to find the acidity. What is acidity? Acidity means number of replaceable hydroxyl groups, OH minus, hydroxyl groups present in one molecule of a base. It is classified into monoacidic base, diacidic base, triacidic base. The first one, monoacidic base, it is a base that ionizes in water to give one hydroxide ion per molecule. For example, Na plus OH minus, only one hydroxyl ion can be replaceable one. KOH, K plus OH minus, only one hydroxide ion can be replaceable one. So these are the examples of monoacidic base. Diacidic base is a base that ionizes in water to give two hydroxide ions per molecule. For example, CaOH twice, calcium hydroxide, magnesium hydroxide, 2 OH. Here hydroxyl group is here the 2. So how many hydroxyl ion can be a replaceable one? Here also 2 and here also 2. So it is an example of diacidic base. Triacidic base is a base that ionizes in water to give 3 hydroxide ions per molecule. For example, aluminium hydroxide AlOH thrice, ferric hydroxide FeOH thrice. Here 3 OH, OH 3. So here 3 hydroxide ions can be a replaceable one. So these are the examples of triacidic base. B. Based on their concentration, it is classified into concentrated alkali and diluted alkali. What is an alkali? Bases that are dissolved in water are called as alkalis. The first one, concentrated alkali. It is an alkali has a relatively high percentage of alkali in its aqueous solution. So in a solution, the percentage of base is a high percentage. It is called as a concentrated alkali. Dilute alkali is an alkali having relatively a low percentage of an alkali in its aqueous solution. So in a solution, the percentage of a base is a low percentage. It is a diluted alkali. The third one, C, based on ionization, it is classified into strong bases and weak bases. Strong bases are bases which ionize completely in aqueous solution. For example, sodium hydroxide NaOH, potassium hydroxide KOH, Na plus OH minus, K plus OH minus. Here this OH minus, they ionize completely in a solution. So these two are sodium hydroxide and potassium hydroxide are strong bases. Weak bases are bases that ionize partially in aqueous solution. For example, ammonium hydroxide, NH4OH, calcium hydroxide, CaOH twice. So these bases are partially ionized in a solution. So these are the examples of weak bases. Properties of bases. They have bitter taste. B. The aqueous solution have soapy to touch. And C. They turn red litmus paper to blue. D. Their aqueous solutions conduct electricity. E. Zinc, a metal, it reacts with the base NaOH to form salt with the liberation of a hydrogen gas. Na2ZnO2, sodium zincate, Na2ZnO2. Now here in this side 2 sodium, so here I put 2. Here 2O already, here already 2 is here. 2H, here already hydrogen is balanced, so it is a balanced equation. A metal react with the base to form salt with the liberation of a hydrogen gas. A base, calcium hydroxide, it reacts with non-metallic oxide, that is carbon dioxide, to form calcium carbonate and water. A base react with non-metallic oxide to form calcium carbonate and water. G. Neutralization reaction. A base KOH, it reacts with an acid that is HCl to form salt and water. KCl, potassium chloride and water. So a base reacts with an acid to form salt and water. This reaction is called as a neutralization reaction. The last one, NaOH, a base. It reacts with ammonium salt, ammonium chloride. If you are heating, what happens? It produces the ammonia gas. First, it produces the salt NaCl and plus water plus ammonia. NH3, ammonia is a gas. You have to put the upward symbol. So a base, it reacts with the salt to ammonium salt to form NaCl plus H2O plus ammonia NH3. So these are the properties of bases. Uses of bases. Sodium hydroxide, NaOH. It is used in the manufacture of soap. Calcium hydroxide, CaOH twice. It is used in whitewashing of building. Magnesium hydroxide, MgOH twice. It is used as a medicine for stomach disorder. Ammonium hydroxide, NH4OH. It is used to remove grease stains from cloths. These are the uses of bases. Now come to the last topic, that is the test for acids and bases. The first one, A, test with a litmus paper. Okay, look at the picture. This is a blue litmus paper. You dip in an acid, it changes into red. In red litmus paper, you have to dip in a base, it turns into blue in color. So in acid, it turns blue litmus paper to red. A base turns red litmus paper into blue. Second one, test with an indicator, that is phenolphthalein. In acid, this is an acid, it is a base. Now in acid, you add 1 drop of phenolphthalein, it is colorless. In base, you add 1 drop of phenolphthalein, it changes into pink in color. So in acid medium, phenolphthalein is colorless. In basic medium, phenolphthalein is pink in color. The third one, test with an indicator methyl orange. This is acid. It is a base. In acid, you add 1 drop of methyl orange, it changes into pink in color. In base, you add 1 drop of methyl orange, it changes into yellow in color. So in acid medium, methyl orange is pink in color. In basic medium, methyl orange is yellow in color. Now, what are the indicators here? Litmus paper, phenolphthalein, methyl orange. In acid, a litmus paper, blue litmus paper turns into red. In bases, a red litmus paper turns into blue. In phenolphthalein, in acids, it is colorless. In base, it is pink in color. Methyl orange, it is pink in color in acid, and in base, it is yellow in color. These are the test of acids and bases. Thank you, students.